So again, just like we had the chain rule went into the general power rule, we have the general power rule for integration. It's absolutely no different. This is exactly what we've been doing the entire time. Nothing different right here. It just says use your U substitution and integrate like you do. Again, this is something we've already been doing. This is nothing new to us. So let's look at example 7 here. 7a says find the integral, the indefinite integral of 3x times 3x minus 1 raised to the 4th dx. Again, this is a problem where technically, you could distribute and FOIL all that out, but that would take way too long, so let's use our U substitution, and that's what I expect to see on the test. So what we're going to do is let U equal the inside. In this case, it would be 3x minus 1. Step 2, again, is going to be find the derivative of both sides. So this is going to be du dx equals, well, the derivative of 3x minus 1 is 3. Step 3, solve for that dx. So I'd have dx equals, multiply both sides by dx, divide both sides by 3. I'd have du over 3. Now I need to substitute that in. Anywhere I see a dx, I'm going to put du over 3. And anywhere I see a 3x minus 1, I'm going to put a u. So I'm going to rewrite my integral now. When I rewrite my integral, it's going to look like 3x times, instead of 3x minus 1 to the 4th, it's going to be u to the 4th. And then instead of dx, I have du over 3. Again, notice here that my 3's are going to simplify, but it doesn't look like my x's simplify. So I need to go back and I need to look at my u. Is there something I could do for u to solve for this? And in this case, I can. So if I have u equals 3x minus 1, I can add 1 to both sides. I'd have u plus 1 equals 3x. I could divide everything by 3, and I'd have u plus 1 over 3 equals x. And so the idea is I actually need to make 3 substitutions into this problem, which is a pain in the butt, but I can do this, okay? So let's go back and rewrite our integral. Now it's going to be the integral of, well, the 3's have already simplified, so the x is going to be u plus 1 over 3, and then we add a u to the 4th du. So again, all I did was substitute in from the last problem that green x, knowing that x is u plus 1 over 3. So when I do that, I see that I can pull out the 1/3 constant multiple. This would be the integral of, well, I'm going to go ahead and distribute this. So u times u to the 4th would be u to the 5th. And then 1 times u to the 4th would just be plus u to the 4th. And then all of this is with respect to u. Now it's written simple enough for me to integrate, so I can actually integrate it. 1/3 constant multiple stays there. The integral of u to the 5th would be u to the 6th over 6, plus the integral of u to the 4th would be u to the 5th over 5. And then, of course, we have our plus c. I'm going to distribute that 1/3 to each of the multiples, constant multiples. So 1/3 times 1/6 would be 1/18 u to the 6th, plus 1/3 times 1/5 would be 1/15 u to the 5th, and that's plus c, right? Last step, look, we could do lots of factoring here. We could factor out a u to the 5th from both sides. We could factor out the 1/3 from both sides. There's no point. I'm just going to go ahead and leave it in this distributed form. The only thing that I have to do now is back substitute for that u. So that's step 6, is back substituting for the u. When I do that, I'd have 1/18, and then instead of u, I'd have 3x minus 1 to the 6 plus 1/15 times 3x minus 1 raised to the 5th. Of course, we need our plus c. So I'm going to go ahead and put that answer in the answer blank. 1/18 times 3x minus 1 raised to the 6th plus 1/15 times 3x minus 1 raised to the 5th plus c. Okay. Again, almost certainly when you look at the textbook in this problem, you're going to see a different format of the answer. And that's perfectly fine. It's okay to have a different format of the answer. You can factor things out, simplify them in much different ways, which would help you check your answer in this case, but that's not what I'm looking for. Again, checking your answer is just a nice benefit of this, but it's not required on these particular problems. Okay, let's look at this next problem here. Again, one of our options here would be trying to distribute and then integrating each individual part, but that actually turned it into a more difficult integral that we don't have the integral techniques to solve yet. So what's the easiest way of doing this is through U substitution. Again, when you use U substitution on the test, I do need to see your definition of U. I need to see these steps, these 6 steps formally done. When you look in the textbook, you do not see all these steps. They just put a little bar above it and say this is u and this is du. Well, I don't want to see that. I want to see all of these steps of you doing the math, okay? So in this one, we have two choices. U could be the first one, e to the x plus x, or u could be the second one, e to the x plus 1. And the question is which is the parent function? And in this case, if I take the derivative of e to the x, I get e to the x, so that's good. And if I take the derivative of x, I get 1, so that's good. So what I'm going to do is let u equal e to the x plus x, the quote-unquote parent function. Second step, again, always, is take the derivative of both sides. So I'd have du dx would equal the derivative of e to the x is e to the x, and the derivative of x is simply 1. Step 3 would be solve for dx. Solving for dx by cross multiplication, multiply both sides by dx, divide both sides by e to the x plus 1, I'd end up with du over e to the x plus 1. Step 4, again, what we want to do is go in and substitute in those values. So let's look at those values that we have. Dx is du over e to the x plus 1, and we have u is e to the x plus x. So when I'm making those substitutions, what I'm ending up with is the integral of, instead of e to the x plus x, I'd have u. I'd still have my e to the x plus 1. And then instead of dx, I'd have du over e to the x plus 1. Let me make sure that plus 1's not in the exponent there, like you can see it properly. Now let me cross out those e to the x's plus 1's because they simplify. And I'm ending up with simply the integral of u du. Now that's a simple enough integral in terms of u's, so I'm going to go ahead and integrate. The integral of u is u squared, sorry, let me get black, u squared over 2, or 1/2 u squared, and then plus c. And there's no simplifying to be done, so I can go ahead and do my back substitution, which is the last step. Remember what u was e to the x plus x. So this is the same thing as 1/2 times e to the x plus c. And that should be my final answer. Again, how would I know that's my final answer? I could double check by taking the derivative. In this case, it's pretty simple to take the derivative of this, and you would see that you would get the right answer right away. Sorry, just looking back real quick, when I said you could take the derivative and get the answer, I noticed a misstep. It was u squared, so I have to add the square in to both of those problems. So that's what it was, 1/2 u squared plus c, so that would be 1/2 e to the x plus x squared plus c. Again, the only reason I caught that is because I tried taking the derivative of the answer, and I realized real quickly without that square there that it was not correct. So please, please, please double check your answers. It can save your butt on the test, just like it saved me during this recording.